So we'll look at the relationship that exists. So relation are still in Newton's second law of motion. So relation between force, the relationship that exists between force, mass, and acceleration. The relation between force, mass, and acceleration. And for us to derive this relationship between the three, force, mass, and acceleration, we are going to start by considering the Newton's second law of motion. So we've stated the Newton's second law of motion, and we have seen that the force is directly proportional to the rate of change in momentum. Is directly proportional to the rate of change in momentum. And therefore, this simply means that the change in momentum is given by the final momentum minus the initial momentum. And therefore, we can move ahead. Therefore, force is directly proportional to the change in momentum, the rate of change in momentum, final momentum minus the initial momentum divided by the time taken. Again, we know very well that the final momentum is given by mass times the final velocity. Then we know very well that the initial momentum is given by mass multiplied by the initial velocity. And therefore, it means that force is directly proportional to the rate of change. That is, here we have the rate of change in momentum, final momentum minus the initial momentum divided by the time taken. So with this again, we can move ahead. Therefore, force is directly proportional to, we can factor out m, that is the mass. We factor out mass, so we remain here with the v minus u divided by t. From our knowledge, previous knowledge, that is on linear motion, we know very well from linear motion, we know that v minus u, that is the rate of change in velocity, is equal to acceleration. The rate of change in velocity, which is final velocity minus initial velocity, all over time taken, is equal to acceleration. And therefore, our formula will reduce to F, that is force, is directly proportional to mass, and since we have v minus u over t as acceleration, so we have force is directly proportional to the product of mass and acceleration. So we can move ahead to remove that sign. So we are having the sign of direct proportionality, whereby now we have force is directly proportional to mass multiplied by the acceleration. So when we want to remove this sign and we put an equal to sign, when we want to remove this and put an equal to sign, we are going to have F therefore is equal to, we introduce now a constant, is equal to a constant k mass times acceleration, where k is our constant, is a constant of proportionality. So we want to find the value of k. We know very well that 1 Newton, or a force of 1 Newton, a force of 1 Newton causes a body of mass 1 kilogram to accelerate by 1 meters per square seconds. A force of 1 Newton will cause a body of mass 1 kilogram to accelerate by 1 meters per second, meaning that if our F is 1 Newton, then we want to find the value of k. Our mass is 1 kilogram and the acceleration is 1. Therefore, it means that our k will be 1 over 1, which is 1. And therefore, our formula reduces to F is equal to mass multiplied by the acceleration, because the value of k is 1. And therefore, this is the relationship that we have between force, mass, and acceleration. In this case, where F is the force and the force is in newtons, then we have our m, which is the mass, and the mass is in kilograms. Then we have a, which is the acceleration, and the acceleration is in meters per square seconds. So that is the relationship that is there between F, that is the force, mass, and also the acceleration. We are getting it from the Newton's second law of motion, whereby the rate of change in momentum is directly proportional to the force. And therefore, we have the force directly proportional to the rate of change in momentum. This is the change in momentum. This is the rate of change in momentum directly proportional to the force. So final momentum is mass times final velocity. This is our initial momentum divided by time. We have factored out m, so to have this, and we know that v minus u over t is acceleration, because acceleration is defined as the rate of change in velocity. So we have F is equal to ma, and therefore we put now the equal to sign. We introduce a constant of proportionality. Then we are saying that a force of 1 will cause a body of mass 1 kilogram to accelerate by 1 meters per square seconds, and therefore the value of k will become 1, and therefore we don't have to put the k, because if it is 1, when we multiply 1 by this still remains. So we have that force is equal to mass multiplied by acceleration, and that is the relationship that we have between force, mass, and acceleration. And that is the Newton's second law of motion, and then this is the relationship between force, mass, and acceleration. So at this point, you can be in a position to state the Newton's second law of motion. You can also be in a position to derive this relationship. It is very questionable to, it is examinable. That is, you can be told to derive the connection, that is the relationship between force, mass, and acceleration. And therefore, from what we have gone through, you should know that the Newton's second law of motion states that the rate of change in momentum of a body is directly proportional to the external force producing the change and takes place in the direction of force. And then we've also seen that force is therefore equal to mass times acceleration. So we have some formulas that we've come up with. Then you also need to know that force is directly proportional to the rate of change in momentum. And this formula is what we refer to as the Newton's second law of motion. So you can write it in this form, or you write it in ones, whereby the rate of change in momentum is directly proportional to the external force producing the change and takes place in the direction of force, So I'd like you to do this exercise. You'll do two questions, whereby in the first one you should state the Newton's second law of motion. State the Newton's second law of motion. Then in the other one, derive the relation F is equal to mass multiplied by acceleration. Derive that relation, and when you are told in the first part to state the Newton's second law of motion, you are going now to use the second law of motion to derive the relation, that is F is equal to mass times acceleration. So during our next lesson, we'll be doing some questions on this to apply these formulas that we have been able to derive in this Newton's second law of motion. So we'll do several examples and also some exercises on the same. Thank you for being attentive. Let us meet during the next lesson.